Now, an extra example, we want to find all the points on the graph of yq minus 27y equal x squared minus 90, which the changing line is vertical and horizontal. Okay, so let's take a look at this graph first. Take a look at the graph of this equation first. You can use decimal to kind of visualize this. So yq minus 27y equal to x squared minus 90. Oh, wow. It's, it's not too good, right? The graph. So this is the graph of the equation that we have early. Look how it look like, right? And now we want to find the point where you have the horizontal tangent line. So look like 0 is one of them. And then I can also have the tangent line right here, and right here, right here. Okay, so there's 4 vertical tangent line and there's 1 horizontal tangent line. But how do we find that? Okay, so to find the slope of the tangent line, we know that slope, whenever the line is vertical, what happened to the slope? The slope m is undefined. Okay, horizontal, the m is 0. So it means this question is just same as asking us, oh, what is the value of x where you have the derivative of this equation is undefined, and what is the value of x give the derivative of this equation is equal to 0. Okay, so all we have to do is find x where f prime equals 0. You're gonna have the horizontal tangent line, and f prime undefined. All right, so it means we need f prime. So all y prime, f prime is y prime. F prime is y prime, so we're gonna have to take this implicitly. So d over dx of yq minus d over dx of 27y equal d over dx of x squared minus d over dx of 90. So now what is d over dx of yq? We just bring down the power and take the derivative, right? So we're gonna have 3y squared. But don't forget every time you take derivative of y, you're gonna have y prime minus 27 times y prime equal, this is gonna be 2x, and derivative of 90 is 0. So now factor out y prime, we have 3y squared minus 27 equal 2x. So y prime times 3y squared minus 27 equal 2x. Now we're gonna isolate for y prime at 2x over 3y squared minus 27. So we want the x value where y prime equals 0. So this equals y prime equals 0. Y prime equals 0. The only thing that can equal to 0 is the numerator. So it's going to be 2x equals 0. So that gives you x equals 0. And that is where the tangent line is horizontal. Now for the y prime is undefined, mean the denominator equals to 0. When the denominator equals 0, mean the derivative function will be undefined. So we're gonna have 3y squared minus 27 equals 0. And that will give us y squared equal 27 over 3, which is 9. So that means y is equal plus and minus 3. However, we are not looking the y value, we're looking the x value where you have the vertical tangent line. So let's see what x value we have. So when y is equal 3, what is my x is? So y equal 3. Put that back into the equation, original equation. We have 3 to the power 27. I mean, no, not 3 to the power 3 to the power 3 minus 27 times 3 equal x squared minus 90. This gives us x squared is equal to 23 to the power 3 minus 27 times 3, and then add 90. So we have x squared equal 36. So this gives you x equal plus and minus 6. All right, so we have two of the vertical tangent line as x equal plus and minus 6. Now we still have one more value, which is y equal negative 3. So now let's try putting y equal negative 3 into here. So we have negative 3 to the power 3 minus 27 times negative 3 equal x squared minus 90. So we have negative 3 to the power 3 minus 27 times negative 3. And then we plus 90, we have x squared equal 144, with x equal plus and minus 12. So that gives you 4 of the vertical tangent line and 1 of the horizontal tangent line, which is match our function, our graph, right? So you have here is negative 12 and 12, 6 and negative 6 for vertical tangent line. Okay, vertical tangent line. And you have x equals 0 for horizontal tangent line, and which is match our graph. Okay, so this is how you find the x value where the function have the tangent line is vertical or horizontal.